Welcome to the Thomas Expert Series. Thank you all for joining us today. I'm going to get started in just a second. Just a reminder, please double check, make sure your microphones are muted. And this expert series will be recorded and placed on demand within 24 hours. So please let everyone know how much you enjoyed the presentation today and direct them to the original page to sign up for some future talks. To get everyone started, let's see where everyone's tuning in from today. Maybe let me know how beautiful the weather is out there, because it's been too hot and now it's beautiful out. Let's see, got Florida, North Carolina, nice and hot in New Jersey, Michigan, Florida, Hotlanta, I love that. Canada, California. All right, let's go ahead and get started. At this time, I'm going to go ahead and turn it over to Valdemar here to talk about reducing risk and achieving goals using 2D coded sample storage consumables.
Perfect, Hela. Thank you very much. Then I would share my screen and start right away. Give it a second. Everybody should see my screen right now. How do you do?
Looks good.
All right, perfect. And let's start. Yeah, first of all, thank you very much for setting this up, inviting me, and giving us the chance to share my experiences and train you on one or another. Very interesting part that we will talk today about. But first of all, I would like to introduce myself very brief. My name is Valdemar Janssen. I'm the Global Product Manager at LVL Technologies, and I worked for 13 years in the automotive industry, did there nearly everything, starting from designing, developing, ending up as a lead developer for BMW, and also worked for Mercedes-Benz and stuff like that. But then it became boring, and I chose to do something with the sense, and swapped to the life science industry. And now I'm roughly already 4.5 years with LVL. And during all my career time, I built now over 587 injection molding tools. So you see where my hobby horse is. And my background is mechanical engineering and technology and innovation management. Also, a brief introduction of LVL Technologies. That's a company that has its headquarters in Germany, in Crailsheim. It was established in 1984, and it figures as a developer and manufacturer of 2D coded sample storage systems, but also for cappers, tube laser markers, deep well plates, and other consumables. But today, as you can see, 2D is highlighted, and this will be also the main topic or focus of the subjects that you can see here in the agenda. That will be once the optimization of sample storage in general. Then we will come to a sustainable consumable solutions that we will provide. And we will have also an introduction into the tube laser market, because it still creates a lot of attention and people are asking for that. All right, let's start with the first topic, optimizing sample storage. So the problem that we are facing, although the very advanced people that are aware of 2D coded systems that are on the market, for them it's probably surprising, but there are still big numbers of users that are using cryo vials with 1.5 or 2 milliliter volumes, and they are in most cases arranged in a 9x9 or 10x10 cryo box format. And the height of those cryo boxes is also pretty standardized. It's in between 50 and 53 millimeters. And what we figured out during the year, and what our experience is, and also the feedback from the customers, because we are asking them, is what kind of sample volume are you specifically working with? And in very many cases, we see that customers use way less than 1.5 and even way less than 2 milliliters, just because of the reason that they are used to work with those formats. But in the end, it means that in worst case condition, for example, if you would go for a sample that has only a requirement of being about 0.3 milliliters big or wide or whatever, and you would store it in a vial that contains up to 2 milliliter storage, then you have a real usage of only 15%. That it means from the other perspective, you have a loss of 85%. And in another consequence, if you think forward, that means that you try to freeze more air than the sample content. And this is a tremendous waste of energy, lab space. You need also more freezers. Then you have a consequence of those. That means you have preventive maintenance or maintenance costs in general. So things are adding up if you start to work with a non-proper, non-optimal vial for your sample requirements and demands. The result is more or less high costs all over. And the solution would be to really look upon what does the customer need. So ask always the customer for the sample volume that he's looking for or working with. And then please find the appropriate vials. For example, LVL has the solution, and during the years we have adopted a wide range of different vial types and volume contents. So we're talking here about working volumes when I name the tubes. So this would be a 300 microliter, 500 microliter, 1000, and those are external in a 96 format. Those are internal in a 96 format. This is a 500 and 1000. And then we jump over to a bigger format, SBS 48. There we start with 500, 2000, 4000. And for the 24 format, we go like 2000, 4000, 6000, and 8000. So that means there is a large variety of vials that meet the criteria, respectively the demand of the customer, more specific. And in addition, of course, the vials themselves in terms of risk mitigation and so on, they have a lot of features that I will come back later on. But just to name them, as you could hear them already, so all the tubes, they are pre-specified or pre-lasered with the 2D bottom barcode, which is unique. Of course, then they have the only cap in the world for the moment, which is IATA and CO2 tested and were found to be 100% proof. And we have additional redundant side codes in human readable and in code 128 1D barcode. So this is just it gives you another security in case one or another code would be scratched or whatever, then you have the redundant code and still the sample would not be lost. But let's coming back to the optimization of the storage and choosing the right volume. So we made recently an investigation on what would it mean if you would, for example, take the standard cryo box and would swap, instead of the cryo box, you would swap to an SBS format. And we found that already swapping from cryo to SBS would give you, like if you start 9 times 9, then you end up with 81 vials. You would go to 96 vials for SBS. This is already a gain in capacity of plus 18%. If you then even manage to swap in a special SBS format, which is the high density format that allows you to store 138 vials on the same footprint, this would be even a gaining of 70%. And in addition, you require a less footprint area, and you save up to 42% in the area. You can see also you can see and compare it here visually. Another thing that comes in conclusion is also that the height is pretty standardized. If we go for the 1 ml tube, it would be similar, but you see the more we go downwards, it makes a significant difference. And what would it mean if we continue to look upon these and take our case study up front? So in case somebody would store a very small amount of sample, that it would fit also into a 300 microliter tube, then you can see here the comparison. Let's assume you would fill up a freezer with cryo boxes, and the freezer is or can be filled with 46,000 samples roughly. If you would go to SBS, you could already on the same or in the same freezer, you could store 165,000. If you would choose the HD and the corresponding 300 microliter tube, you could store up to roughly 238,000. And what does it mean? You can see the numbers on the bottom. This is the additional capacity that you can put in the same freezer compared to the cryo boxes. So this is really a tremendous difference. And what it ends up in is, instead of 5 freezers that you would need in case you would work with cryo boxes, you can use only 1 freezer. Means that you can, or the customer can save the money on the freezer. In addition, it can save him CO2 exhausting numbers. Also, it can, like energy consumption, which is then resulting in cash, of course. And the average cost saving was calculated for above 100,000 for 100,000 samples. And so if you have more samples, then those numbers would add up in addition. And as a conclusion, again, like if you look upon it from the other side, the reduction of CO2 is about 80%. So this is significant, and don't underestimate really the number of people that are still working with cryo boxes. And this is very relevant for every lab that is starting, for small labs, and even still for mid-sized labs and mid-size, I would say, throughput related consumption. Oh, sorry. All right, then let's right away. Afterwards, I'm sure you have plenty of questions. Afterwards, we can deal with all of them. But I would try to stay in time and to provide you as much information as possible. Sustainable consumable solutions would be the next topic. And we also, back in the years, we started in 23, we saw that there is one problem that appears, and we see that the customers, once we're getting in their labs and so on. So this was like the previous topic was for small and mid-sized labs, while this topic is probably for bigger throughputs, for bigger labs relevant. So if you have mass storage of samples, then you probably have customers that are working with special freezer systems, like either from Hamilton or SPT or Lyconic, Astion, whoever. And the systems, they are often using internal racks. We know that, to optimize also the storage capacity. What makes sense, it's definitely good. However, they don't need the racks anymore. And you can imagine that this is causing high volume of plastic waste. And this is, for example, now one of the things that we see is, this is a special shelf cabinet where the tubes are taken out of the original racks where they were needed to aliquot them accordingly and to do all the studies and store the samples properly, also to have it in the LIMS system and everything. You're aware of that probably. But then for storage, they are rearranged into those high density internal racks, and then theoretically the racks are getting scrapped. So there, or I made a case study on base of that, a search for a customer. So in this case study here, it is one customer. I researched on the weight of one rack. It would be 145 gram roughly, and the time scope that I researched this project on, and the number of racks that we produced for it. And it was about roughly 385,000 racks for this single customer. And the application was, it was a single tube storage for a short time, and that was a subsequent disposal, and that means also all the racks, the lids, everything was scrapped. And we researched on the plastic, on the original resin consumption. It was about 55.8 tons. We also made a research on what it meant in the end. Yeah, so you see the input for creating this amount of plastic for oil, water, and energy. And it was huge. And the output for getting in the end 55.85 tons of resin required, for example, 88.8 tons of oil. For example, those are huge numbers. So I thought myself, okay, we have to figure something out to improve our responsibility also on sustainability. And the solution is the recycling of single-use racks, including the lids and including also the closure mechanism. So what we have done is we took part of the racks, lids, closure mechanisms back. We shredded them and we were remelting them. It was also, this is now a filling study. As you can see, it is 100% recycled material. And those are just different filling studies or filling states. And this was then the end result. And this is pure recycled material. So we were successful in that. And as you can see, it started in 23, but already in 24, we had already produced the very first pilot project with a customer. We presented this one here in Berlin at the National Biobank Symposium. And together with this customer, then that came right across to us at the fair and said, okay, we want to participate. So we gathered together from him. We collected the racks, took it back, remelted it, and produced new, I would say ecologically, because you can see it's really 100% recycled plastic, ecologically new lids for them, new racks, lids, like a whole closure mechanism. And so on. So this is very, very unique. And what does it mean? We researched upon how many times we can recycle it. We found that it is easy for us with our injection molding tools, processes that we have, and quality insurance that we have. We can recycle it up to 10 times. So if you take into account the initial part that you're producing and then recycle it 10 times, then you can save up until 91% of the input material, because you're reducing the required material for this case study, for example, to roughly 5.6 tons, which is amazing, right? So this has real power to not only greenwash, but really to provide a greener footprint, I would say. All right. Then let's move on to the introduction of the TLM, because that's also a pretty hot topic nowadays. The cryolines, they are commonly neither coated or maybe bottom coated, but no, bottom coated, they're even not bottom coated. They're more normally blank, I would say. So the most people that are coming to us who are interested in the TLM, they are still labeling those by paper, by hand. And this is very time consuming, because you can imagine how much labor force you need for that if you have a higher or a mid throughput. And also the quality suffers from that. So if they used paper labels, they are restricted in specification and application. Also the quality of the handwriting, how silly it sounds, but it still can affect the quality. If you can't read what somebody wrote on, then the sample integrity, or respectively the sample traceability, is lost, and this is a very, very huge risk. And of course, the quality of automated printer varies. When you have an ink, for example, then they're often not chemical resistant, or the expiration date is in average 3 to 6 months. So also here the costs for maintaining them will be pretty higher, and the outcome of the quality is not that good as it would work with also like automation freezer solutions. So we made also, when we were investigating on this recycled solution, we were also researching on the very latest state-of-the-art adhesive laserable foils ourselves, and this is what we found. This is, for example, now a picture from a customer that we received. Yeah, so he's using paper labels. You have your folds, and other stuff that can create problems if you try to stack it into a rack or whatever. But our findings were those. So if you drop them in liquid nitrogen, the risk is still nowadays huge that they're just falling off. Even if you put them into -80s, you see that most of the label was still sticked on, but after several times taken out and taken back, we saw that it started to become loose. So for us, it was no solution to use those kind of labels to avoid falling them off. Yeah, so the risk was too high for us, and we also don't recommend our customers to do so. So our solution is to go with the 2D coded tubes that are laserable. So of course we can also provide the solution where we, in our serial production, do also customization or standard codes or whatever, so that you can see it on here. But in addition, of course, we can provide you a laser system that is kind of a small, very small version in an abstract way of our serial production that gives you then the freedom and ability to put upon the tube on the sides like whatever you want and on demand. So that means if you don't know today what you will put on tomorrow, what is logical, then you could do it yourself with the TLM, and we would supply you with a tube which would be pre-coded on the bottom but would be blank on the sides. And you can see here pictograms, all different kind of symbols, characters, fonts, and so on is doable. And this is actually a customer's tube, so that's the reason why I had to censor part of it. And the way it differs itself from a paper label is the physics behind it. So there is a laser additive inside the black material. However, important to know, the transparent material, which is in contact with the sample, is a closed sleeve. So that means this is over molded. The black area is over molded over the transparent one. That's important because here, of course, you have color pigments, and the transparent one is super pure. So the color pigmented part does not get in contact with the sample. However, this laser additive here helps us to create a microfoam, which we have measured here with a very latest 3D microscope. And we found also, for our research, it was like we wanted to know about the height of the foam. And this is actually the picture, and you can see it. So there are little, I like to call it popcorn effect. So once the laser is hitting the laser additive, it starts to foam up. So it is a physical transformation of plastic. So you cannot wipe it off. It is actually real. It's the same resin, the same basis polymer as you use to create the tubes for. And what you can see here is that it protrudes out, but what you don't see here in this measurement is that it protrudes also within or into the wall thickness, and this gives you additional safety in terms of durability and abrasional resistance. So even if you start to scratch it off, the likelihood that you still can read it, at least the part which is gone into the wall thickness, is very high, and this makes a huge difference to paper labels where the layer is pretty small, and in case you would scratch it with any sharp object, then the paper label would be gone, the code would be gone, and accordingly your risk would be high to lose the sample's information. And here is a brief demo about how the system runs that we're using to code the tubes in the customer's labs. So we have there a tray that allows you to position 9 racks. A handheld scanner comes along with the unit. You would scan the racks barcode. You would position it at any of those 9 racks, and you would scan the number or the special barcode of the corresponding tray position. That way the machine knows then at which position which rack is allocated, and then you would assign a laser program which is CSV based. Yeah, so this is how it looks like. It's more or less, so everybody who can deal with an Excel can deal with the input files of the TLM. It's really straightforward. And once you apply it, then the laser does put it up. You can see there is a robotic arm. It takes it from the rack, lasers it, checks it, and puts it or sets it back into the rack again. There are some tech specs, and we can talk about those later. And this is a picture or a video that I took at one of the SLAS venues, and this is real time. This is also the real lasering speed, so you can see it runs very, very smooth, very fast. Gives you the ability in average to do about 500 tubes an hour. So that means if you have smaller tubes, theoretically you could be even faster. If you have bigger tubes or a bigger amount of information, it might take longer, but in average 500 tubes, which is an awesome result. Right, this is the spec sheet that you can also download in the flyers section of the kiosk of Thomas Scientific. Right, so what is important to mention: CSV, 500 tubes, 9 rack positions. Right, and as you could see in the demo video as well, it works with 96, 48, and 24 formats without the requirement of make any adjustments to the head or to the grip or whatever. Everything is built in such a way that it is capable of doing that automatically. All right, so that would be the presentation. I'm very thankful that you participated so far, and I am sure that you have also one or another question.
And while everyone is typing out their questions, I just want to take a moment and share my screen with you. Perfect. I know he did talk about some of the literature, and that will be inside the kiosk. There's also some web links as well as some videos. And you can also find this talk on demand, and you can also register for upcoming talks over here. And I'll hand it back so we can get some of these questions going.
Hey, Waldemar, this is Kat from Georgia, or Florida, sorry. How many lines can you print on each tube?
Excuse me, how many?
Yeah, like how many lines? Like, can you put like 4 lines, 5 lines, 6 lines?
The limitation upon how much information and how many objects you can put on the tube depends on the size of the black patch that you have. So that means if we, and I would share for that my screen again. So for example, if you check out this picture over here, it's arranged just in the way you would also arrange it on a paper label or using PowerPoint. So you're not limited. The limitation would be the area of the black patch and the font height that you would still find good for being readable, right? So theoretically, you could squeeze that down that you're getting multiple lines here, but the question is then how comfortable do you feel still reading it?
And then how many, does it just do LVL tubes?
It works with any tube that provides the same technique. That means if it is or if it contains the special laser additive, or it is a laser compatible foil, then it works. Yeah, so we have done already also systems like this. However, I have to admit, of course, with LVL tubes, we can ensure and guarantee that it will always work. And in case of any modification of tubes, recipes of additive material mixture, whatever, our system will be compatible and will work. However, for other consumable producers or vendors, we could not give this guarantee because we will not be informed about it. So in the end, the customer would be kind of in charge of informing us that he's facing some changing in the market or whatever. Yeah, so this would be a risk that we would have to talk to or address to the customer.
Thank you.
Very welcome.
There is a question in the chat. What if I'm interested in using recycled racks? However, shipping the racks from the US back to the EU for recycling doesn't make sense from a sustainability point of view. Is there still a possibility to get these recycled racks?
Yes, sure. So also for that reason, I would maybe share the screen again. So when okay, in this particular pilot project that we had here and started in 23, we did it together with a very well-known company from Germany, so it makes sense to took them back and forth. And since we're producing also in Europe, it is easier for us here to consider taking back stuff as well to obtain resources. However, for every plastic manufacturer, if you start to producing, you have always a ramp-up time. So that means up until the point where you are producing within specs, you produce a lot of parts that are getting scrapped, even if it's perfect virgin material. And this scrap, so nowadays, since we started it, we are collecting this as well. And then we have the ability to shred it within the production. It is a separate controlled quality related room. There it's getting shredded and is produced in the same way as shown here. So that means even if, especially for America, it would be relevant, or other, for example, foreign Asian countries or whatever, it would not make sense to take it back. We could still supply them with recycled tracks, because back in the days, those scrap parts, they were scrapped. Yeah, so this was a waste of resources, and you can imagine that there are a lot of parts. Also, all the tool trials, for example, if you do a revalidation of the tool and its capabilities, then you're producing maybe sometimes 3 days of pure scrap. This is plastic manufacturing. This is relevant for all plastic, like all over the world, and nowadays we can make a difference. So that's the reason why I'm saying this is no greenwashing, but this is real something that you take, and normally it would be maybe burned somewhere, and instead of that you produce a new part. So that is doable. Yeah, we can supply you with that.
How would you get the jobs transferred to the TLM?
There are multiple ways. We found also for those TLM that we have already installed, we found that it's really related to the customer's needs, to the throughput, and of course to the IT security. And it's like, of course, everybody wants to have something else, but in the end, there are several ways. The easiest way for smaller labs would be probably to create the CSVs directly on the TLM itself, because it contains a built-in computer. Another way would be creating it on your workstation and transfer it by USB, doable. However, of course, in bigger companies, the restrictions are higher. This is not possible. So there are 3 ways of connecting the TLM to the network. One would be creating a SEMPA connection. Another would be placing a communication laptop in between that has a spare or a special server or network card, and we would then connect the TLM to the laptop. The laptop would connect to your network, and this is probably the most safest solution, although connected then with a bit higher effort. But that would mean that you could sit on your workstation, you place somewhere on your network a jobs folder, and then you take the CSV templates that come along with the unit, you store them there, and you just copy paste them, fill them out in the way you need them, or you let a list like a LIMS system export them in the way you need it, while maintaining the format that the TLM can work with, and then you could share it that way. Yeah. So those are probably the the most relevant applications. Yeah.
I have one more question. Does it only take CSV files or can it take Excel as well?
It takes only CSV because it is then easier to translate it into the servers which are running in the background. So it has a communication base. However, once you operate with the CSV, you can open it with an Excel. So the templates, they're already saved in CSV. And when you open it with an Excel, it will be still CSV if you oversave it or save it twice. So it will look like Excel and you will work in Excel, but it will be CSV in the end.
Thank you.
Anyone else have any questions? All right. Thank you very much for joining today. And I hope you all have a great rest of your day.
Thank you.
Awesome. Thank you very
Thanks
much,
so much.
guys.
Thank you for our presentation.
Thank you.
Thank you.
Have a good
Thank you so
Bye.
much.
Thank you.